Welcome geometry students to 9.2, and it's actually 9.2 day 1 because 9.2 has 3 days that we'll go over. The first day is going to be dedicated to circles. We're just taking one short day for this one because a lot of stuff about circles you already know. You probably have the area and circumference formula memorized even, so we're only going to spend one day on this, and then we'll spend day 2 and day 3 on regular polygons. So let's firstly dissect a circle and look and see all these different pieces here. The first thing that we need to know is what that segment is called and what that does for us. We're going to label that as BC. So in that case, that is our diameter. That is the distance from one side of the circle or one circumference to, or one point in the circumference to another point on the circumference that goes through the center. And we label that like a segment because the diameter is BC. In this case, it's a segment. And then we also need to know what radius is. Radius, you could call it radii, I suppose, would be another plural of that. And that goes from the center out to the edge right there. And I'm going to call that D, for example. And so AD would be the radius, but there are multiple radii. There's actually 3 that are drawn here. Another one that exists is AB. Another one that exists is AC. So there's lots of radii that you could find. And then lastly, how we label this circle is we call this circle A. So we label it by using that center point. And this is an important thing to remember, just like when we were learning how to label points and we put like a little point P and we'd call that point P. Just like when we're labeling other things like segments and points, we need to label our circles appropriately. So let's look and see the 2 different formulas that you could use. The circumference formula is pi diameter or 2 pi r, and that's because the diameter is 2 radiuses, and so that's why both of them have pi. One of them has a diameter and one of them has 2 radiuses. And then the area is pi r squared. And you probably have those memorized. If not, they're on your pink formula sheet, or you could write them down here. And let's look at an example like this. So what if I gave you this circle and I said, here's the diameter. The diameter is, let's say, 16 centimeters. So, I'm sorry, 18 centimeters is what I've written down. Let's use that. And so I'm going to plug in that diameter. Now for the area though, I can't use the diameter. So we need to recognize that the radius is half of that. So the radius in this case is 9 centimeters. And let's plug in the radius and the diameter to find the circumference and the area. This should be something that you know how to do. The circumference in this case is pi times diameter. I'm going to plug in my diameter there. So my circumference is pi times 18. Now if I asked you for your as simplest answer as possible, that is going to be your exact answer. Of course, centimeters at the end there. But that's not exactly what I'm looking for all the time. I might actually ask you for your rounded answer. And why don't we round to the nearest hundredth? And that would be your rounded answer for the circumference. And let's look at the area here. We're going to take our radius that was not given to us, but we were able to find it here, and we're going to plug that into the area formula. So my area is equal to pi radius squared, and I'm going to plug in that radius, which is pi 9 squared. Now hopefully you can do that 9 squared in your head. Sometimes it won't be as simple as that, but that's going to give us 81 pi centimeters squared. Again, that's our exact answer. No one can argue with me. If I say it's 81 pi, everyone goes, okay, yeah, it's 81 pi. Whereas the rounded answer, which is 254.47 centimeters squared, some people might say, well, actually I plugged it in and I got 48, or oh, I rounded differently and I got 47, which is why we call any answer with a pi in it, it's exact. No one can argue that it's not 81 pi. And then we have our rounded answers down here.